Hi, in this video I'm going to demonstrate how to model this 3D printable key tray by using surface modeling tool. This is also a good exercise for a CAD beginner to learn the surface modeling. Okay, before we get started, CAD modeling functions are classified into two categories. One is the solid modeling, and the second one is the surface modeling. All the professional CAD software, they share this same structure of the function. It may be called a different name in the different brand of the software, but they are basically the same function. In this demonstration, I will use Autodesk Inventor, but you can also follow this exercise using Fusion or SolidWorks, CAD or Solid Edge. Okay, for the main function of the solid modeling, we have extrude. This is the most used function in CAD, revolve command, sweep command, and loft command. These are the major four main function of solid modeling. But the loft command in Autodesk Inventor is a bit special because it can loft with 3D rails, same as the Fusion. So you can replicate almost every surface using just the loft command. So when I do a reverse engineering video, I often use this command to reverse a complex surface. It's very fast to reverse with the loft command. Okay, for the surface modeling, we have a main function, a patch surface. Patch surface will create a surface by using sketches. So either a 2D sketch or a 3D sketch. And we have a rule surface, similar to the extrude function, a trim command that used for trimming one surface with another surface. The most important one, stitch command. Stitch command, it can be called differently in other brand of the CAD software, but stitch command will convert watertight surface into solid, because at the end you have to convert surface into solid, either for CNC machining, 3D printing, or making a 2D shop drawing. You need to convert surface into solids to be able to do that. And everything around you is made by these 8 commands. Your car, your television, your phone, everything around you is designed and created by using one of the 8 commands here, or in combination of these 8 commands. This command need sketches to be able to execute. Reverse engineering is exactly the same as CAD modeling. It's just that you use 3D scan data for reference. Basically speaking, all professional CAD tools can't do reverse engineering. You only have to learn how to model it. There are some CAD software that advertise that they are made for reverse engineering. I would say here that it is a lie. This is in Autodesk Inventor. I start by creating sketch on the XY plane. The first ellipse will be the base of the tray, and the second ellipse will be the top edge of the tray. You can adjust the size to your liking. There is no right or wrong here. My top edge is 180 millimeters long. Next, I create a sketch on the XZ plane. Then I project the tip from the first sketch and create a vertical line for the reference. Next, I draw a 3-node spline and adjust the curve. I do the same for the sketch in the bottom of the tray. I use arc. So now we have two 2D sketches on 2 planes. I create a new 3D sketch and select 2 of the curve for intersection. The yellow curve you see is the product of the intersection curve command. Next, I do the same for the top edge. Click on the 2 sketches and create intersection curve. Now we have 3D curves that create from 2D sketches. In 3D sketch, I create two of the splines, add one vertex for each spline. Then I move the vertex to adjust the curve. Next, I'm going to mirror the curve using the XZ plane. Now we are ready to make patch surface. Under patch command, I click on the boundary curves. Do the same on the opposite side. And in the bottom face and the top face. Next, I will select all the patches and click on stitch command. Click on apply. Now I have a solid. Next, I'm going to create a wall by using a shell command. The wall thickness is 2.4 mm, and I click on the top face to remove it. Next, I add the fillet along the edges. Because the bottom of the tray is not flat, so I will create a leg support, two of them. This 2D sketch will be projected onto the curved surface of the tray. I create a new 3D sketch and then I use a project to surface command to project these two 2D sketches onto the surface like this. I do some size adjustment from 5 to 8 mm to make it look a bit more sturdier. Okay, next I'm going to create a new part that is the leg support of the tray. I move this plane up for 6 mm, so the leg would be a bit taller. I create a sketch and make a thin slot profile, a little bit longer, 55 mm, and then I project the curves 3D lines from the tray and create the profiles of the leg by using a 3D sketch. Next, I'm going to turn all these 3D lines into a surface using the same patch surface command. This is how the designer create car panels, bumper. They all use this approach to do it. This is the reason you don't find any flat surface in the automotive part. I add two more 3D lines here to control the surface. Okay, now I have watertight patches to the shape that I like. Next, I select all the patches and click on stitch command, click on apply. Now I have a solid leg support. To make it a bit more interesting, I create a 2D sketch here and draw an arc. Make an extrusion cut. Next, I'm going to create a plane on the leg support and draw a small rectangle. This will be the key, alignment key, so that I can align it after I apply the adhesive. I add a small chamfer on the corners for easy fitting. Add fillet along the edges. Okay, next I do the same for the leg support on another side. Just creating 3D lines and use it for the boundary for the patch surface. Because this one has a different shape, it's longer, and the projection curve is different from the first one, so the first leg support cannot be reused. I make the same arc cut out in the bottom to make it look like a leg support, and then I add the key, the alignment key on the top, same size. Okay, next I go back to the tray and project the key from the leg support, offset it to 0.2 millimeter and make extrusion cut on both sides. Okay, now the modeling is done. Okay, here's the final result. I'm going to print this with a light green color, a PLA filament, and for the leg supports I'm going to use the black color. Okay, in the slicer I need to find the orientation that it would work with the minimum support, so I decide to go with this orientation and it should work, but I'm not sure after support removal how is it going to leave the mark on the surface. Okay, it's not the best print in the world. As you can see, there's some defects from removing the support. I've tried to sand it, but it's still there. See here, it's matched perfectly. Apply some adhesive. Just need to apply some pressure. There's a bubble glue here. Just leave it, just an example. You can use a Q-tip to clean it. I have it here. I'm gonna use less glue this time. Yeah, just leave it to cure. Okay, here we go.